Right, so as you said, my name is Steve Polyak. I'm from a company called ACT. Most people know us, of course, from the ACT College entrance exam. I imagine several of you have taken it at some point. We're actually the leading college entrance assessment right now over the SAT. Most people don't know that actually the ACT is a not-for-profit organization with a mission to help people achieve education and workplace success. We actually have products that address the entire continuum of what we call K to career, so it's appropriate for us to be slotted in the session on lifelong learning. In particular, I'm with a relatively newer division of ACT, we're called ACTNext, unimaginatively. We're led by a woman named Alina von Davier, who's a computational psychometrics researcher that some of you might already have known. I know we just hired some additional people on our team that I know are collaborators, like Michael Udelson, other people who you might know from the community as well. Alina was with ETS for many years. Our focus is on extending ACT's mission through research and development using psychometrics, machine learning, artificial intelligence, data mining. And we have a group of research scientists, technologists, and are forming various partnerships with various collaborators and consultants. So the title of the talk again is Analyzing Game-Based Computational Collaborative Problem Solving with Computational Psychometrics. And I just wanted to share again some thanks to several people that we've worked with as well. First of all, our intern Kiana Hanjani is getting her PhD at Iowa State University, and she's with us all summer. Several people from ACT, which includes research scientists, as well as content experts and technologists. We also worked with Yigal Rosen, if anybody has met Yigal before. He is from Harvard's Office for Advances in Learning, and he's done quite a bit of work on collaborative problem solving with PISA assessment. And then last but not least, Joan Severson is a researcher, innovator. She owns a company in Iowa City called Digital Artifacts, and they helped us build the game that I'm going to talk about. So for this talk, right, I want to talk a little bit about something called the holistic framework, as well as the connection to lifelong learning. And then within that, I want to highlight some of the cross-cutting capabilities that we're focusing on. And then within that, I want to talk about collaborative problem-solving skills in particular. We'll consider the game that we've built, and I'll share some details on the research studies we've conducted. And then we'll talk a bit about what is computational psychometrics, and with the techniques. And if time permits, I'll touch briefly on what we're trying to do with the skill evidence that we're gathering. So let's start with an individual that's at some point in her lifelong learning journey. Maybe she's getting ready to apply to college or enter the workforce. So the question is, what does it mean to be ready? What kind of knowledge, skills, abilities, or other characteristics would an individual need for these different goals? Let's say, for example, to be successful in the first year of college. Well, ACT has been addressing that question from an academic standpoint since the late 1950s. We created what's called the College and Career Readiness Standards that define these skills needed to achieve a B or better at college level classes in English, math, reading, and science. We also we can evaluate individuals' academic abilities using the ACT assessment. But you're probably all familiar, actually it was just cited earlier too, about some of the additional aspects of what it means to be ready. Researchers such as Angela Duckworth's work on grit, Carol Dweck's work on the growth mindset. There's a lot more to being ready than just simply your academic preparedness. Sometimes we call these non-cognitive or metacognition skills. So ACT has significantly invested in the development of a new framework. It's what we call the holistic framework. And we refer to it really as the gold standard for understanding the connections between academic skills, social emotional learning capabilities, and cross-cutting capabilities, sometimes called the 21st century skills, for example. So in addition to the academic ability, the framework basically describes a range of behavioral constructs, for example. Areas for this include those typically found in social emotional learning, like maintaining composure, sustaining effort, as we just heard about with Coursera, and keeping an open mind along with others. ACT actually recently acquired a new company called ProExam, which has an assessment for this called Tessera, if anyone's interested in that. Adding to this, we have a concept of cross-cutting capabilities. Again, these are things such as critical thinking, decision-making, collaborative problem-solving, and as I mentioned, these are sometimes called 21st century skills. And then last but not least, we have an area of the holistic framework that we call navigational. These are all abilities that revolve around being able to navigate education and career path choices, being able to make informed choices, personally relevant decisions, developing actionable and achievable plans. So, in fact, within managing career and education actions as part of our holistic framework, we also have a construct that we call lifelong learning. And it's defined, as you can see here, as the extent to which an individual engages in behaviors to develop competence by acquiring new skills and knowledge and mastering new situations. But for this talk, what I wanted to do is focus on particular areas of problem solving, mainly within our cross-cutting capabilities. So, as we'll see, we actually pulled out two different sets of constructs for our research, for two different research studies we've conducted. In phase one, we targeted the following constructs. I'll also in this talk refer to them as sub-skills as well. So we see feature identification, things like maintaining a shared understanding. That's like identifying or reconciling gaps in understanding, engagement and interaction, and strategy, as well as evaluate, which is defined as recognizing your own strengths and weaknesses. Sorry, bear with me 1 second. I just lost my pointer on this slide. Okay. So there's two different sets of constructs that we're using, one in phase one and one in phase two. The phase two research actually just wrapped up. We literally just got the data last week before I left. So we did some quick analysis of the data, which is going to be similar, and I'll share with you. But you can see some of the constructs we used in phase two. So the game. So let's talk about using game and assessment of skills. So again, as I said, with the academic skills, it's pretty straightforward. ACT knows how to do that. We've been doing it a very long time. When we talk about these new constructs we're seeing in a holistic framework, the great question is, how do you evaluate things like collaborative problem solving? These are performance-type tasks, and you need different instruments to be able to measure something like that. So, games is not something new to ACT. We've been working with doing what's called stealth assessments for a while now. For example, here is a picture of some work we did with Valerie Schutte from Florida State University, who coined the term stealth assessments, using their physics playground work. And we see also some participants working to solve the challenge. Also, Alina Van Gager, our leader, has done a lot of work with game-based assessments with Robert Mislevy, for example, on the SimCity EDU game. But what we decided to do is we're going to build our own game that would allow us to designate the user experience. So the concept was basically a first-person maze in which a user needs to solve a series of tasks or challenges to win the game. But the catch was that it can only be done by collaborating with a virtual agent. So here's some screenshots. On the right, we can see a dialogue console that's always present. Again, the idea is you're faced with these different challenges, and you have a way of speaking to the virtual agent. The top panel is basically the message being sent to the player from the virtual agent, and the bottom provides a set of responses that the student can choose to respond to a particular situation. So each task and each transition between the tasks has essentially a scripted conversation flow that players can control by selecting different response options at various nodes in the tree. And then all of these conversation events are captured in a game log that we store, and we process it either in real time or we can analyze the game at the end of the gameplay. So here, for example, we have one of our players actually interacting and playing the game. So as I said, we can think about the game really as a conversation tree with a unique tree for each task. So each node in the tree is defined with a prompt, sort of in the same way that an item has a stem. We have these prompts that students are presented with. And then the options the item options or the conversation options in which a player can choose basically to advance the collaboration. So if I blow up one area of the tree here, we can see that there's basically these little red circles that are on the response options. Those are all tagged by the content experts. So the same content experts who built the constructs within the holistic framework for these areas are the same ones who built the conversation flow elements. They're the same ones who tagged these particular elements for performance levels. So for example, if a student picked one of these 4 response options, we might record that either there was no evidence of persistence, there was a low level of persistence, a medium level, or a high level. We consistently use this scale of 0 to 3 for all of our different skill evidence presentations as students pick different response choices. So by selecting a particular response option, we store their interaction in a matrix of sub-skill evidence. All games have 5 different matrices of response options that were chosen. And then what we can do with that is basically create a feature space in which all the scores for the sub-skills can represent a particular game in a unique selected set of options throughout a gameplay. So as I mentioned, we've done 2 research studies with the game. The first study that we did was back in November 2016. There's about 160 middle school children. And then, as we mentioned, we use these particular constructs. And back in NIPS at Barcelona, we presented this work in a workshop on a poster session. For study 2, it's much more involved now. We did a lot of redesign of the conversation flow based on what we learned from the first run of the game. This is all being run now through Mechanical Turk. We had about 500 adults, much older population. We actually had a number of instruments, pre-survey and post-survey. They all took a Hexaco personality assessment. They took a collaborative problem-solving questionnaire where they did self-report. We have them also do something called a situation judgment task assessment that comes from ACT. We have a work keys assessment that does this assessment. And we have a crosswalk between what's being measured in the work keys and what's being measured in the skills of our game. All of this by the way of trying to say what will we have in terms of correlation or predictive capability between these different instruments. So computational psychometrics, again, still a pretty new term. According to Alina, she believes she's coined this term. So what is it? It's basically a blending of classical psychometrics, right? So we start with evidence-centered design, latent theory, IRT, from the top-down theory. But what we're doing is using things like data mining, machine learning, other AI techniques to sort of take the granular data or data from multimodal sensors and bringing it up and mapping that bottom-up data into the top-down psychometric data. So we're extracting features, we're building mid-level representations with different models, and we're connecting them to the psychometric models that were originally created for this research. So it involves a lot of different techniques. As I mentioned, we're doing multidimensional item response theory, mixture modeling. In the paper that we submitted for this workshop, we focused really only on 2 things, non-hierarchical clustering and Bayesian evidence tracing. But there's a range of different things that we're currently utilizing. And so as I mentioned, we literally just got the data last week. We just started to unpack some of the stuff from phase 2. So what we see here are some kernel density plots for particular sub-skills for the population. Again, what we're looking for is normal distributions for the skills. So again, like G is reaching the goal, P is persistence, and so on. We also computed an overall game score that blends together the 5 sub-skills and looked at the distribution. There's a subset for users that have particular game responses. And again, what we see is, it looks like when we blend all this together, we have a fairly normal distributed overall score for the games. In the paper, what we reported about, again, was using a mixture of Gaussian's approach with an EM algorithm to sort of discover clustering of our gameplay. So what we see are just 2 sub-skills in order to do a 2D presentation of the 5-dimension space. But you can sort of see as the EM algorithm learns over iterations. In this case, setting K to 4, we had it learned, a way to classify the different games into 4 different categories. So this was a big question of contention. The problem with people coming up here doing things like this, where they're like, look, hey, we said k equals 4, and we showed you a cluster of things that are 4. Problem is always, well, great, you can cluster pretty much anything into any cluster that you want, whatever k you're choosing. So we spent quite a bit of time walking that back and saying, okay, well, yes, for 4, our learned categories look like this. If we start to drill into that, what we can do is start to use different metrics or indices, like here's the silhouette index from the latest data that we have. So, for example, we said k equals 6 or k equals 5. What are the silhouette indexes saying? Obviously, there's a problem here with k equals 6 with the negative silhouette indicating incorrectly assigned cluster data. We have non-uniform shapes, looking at some of these visualizations for k equals 5. We also ran this too using PCAs on the visualization on the right too. And to make a long story short, a lot of the analysis that we did last week starts us to think that maybe there's not a lot of clusterability here, because we brought it all the way down to 2 clusters now seem to be the most optimal. Again, with the silhouette analysis, we have the mean line, here's the red line, and what we're looking for obviously is to get that as close to 0 as possible. These indexes sort of bottom out at 2, which is a problem. So we calculate the Klinsky-Harbaugh's index for this as well too, which again says, yes, I think 2. And BIC is giving us the same thing too. For those of you who've used dbScan before to do something similar to this, right? Here's the dbScan you would see for a typical iris data set that has 3 clusters well to it. Our dbScan is telling us you really have one distribution of a cloud of information, which is fine. It's normally distributed. There might not be clusters here. And so what we're going to have to do is kind of take some of this data and walk back and see whether or not clustering is actually even appropriate for this work. Moving on, we've done some multi-dimensional IRT analysis for this. Now this is where we're starting to change to look at correlations between the estimated latent abilities between game skill evidence and the evidence from like our work use teamwork, situated judgment task that I talked about before. Preliminary analysis there seems to again suggest if there is a correlation, it's weak, moderate so far, which is not what we were hoping for. So again, we're going to continue to look at the data, but so far, not exactly what we wanted. Sort of the same thing with our Hexaco assessment. So we've looked at all the different personality constructs from the Hexaco assessment against the 5 game features that we have. And again, the correlations, nothing earth-shattering is jumping out of it so far. Some personality trait being predictive of a particular subskill or vice versa. In the paper, though, if you want to learn more about what we did with the Bayesian evidence tracing, it's all there. What we're doing with this is, basically what we have is 3 different hypotheses that we're trying to maintain over time for the game. So either you're high, low, or medium at a particular subskill for all the different 5 subskills. And so what we can see here is this chart shows us that initially, this is just one gameplay. A student sort of spiked initially with high engagement scores, but then low engagement scores sort of took over as they continued to interact more with the dialogue tree over time. And at the end of the entire game, they actually ended up on what we consider to be a medium prediction for their subskill scores. But the nice thing about this is we can actually in real time trace what's happening during the conversation flow as well. All of this work is being done in something new that we created at ACT called our LEAP platform. The LEAP platform is our learning analytics platform. It's basically a data lake where all of our data funnels into now, whether it's ACT assessment data coming live off of our processing of ACT data, or if it's game log data that's coming from the actual games these students are playing. It's all being converged into this single system. And what it allows us to be able to do as researchers is get at all of the data in one place and link with it and work with it all in one way. And so this is all based on the Hortonworks Hadoop platform. If any of you are familiar with Hortonworks. So it's a set of different open source technologies. We're using an open source tool called Apache Zeppelin to actually do notebook style computing as researchers. So we work with the data by creating notebooks, whether that's in Python or R or Scala. And what you can do with that, obviously, then is share those between the research teams. You can create visualizations, work with different machine learning libraries, for example, Spark ML or Scikit-learn. They're all integrated in our platform when we're doing the analysis. Okay, so last but not least, real quick, what are we planning to do with this skill evidence? One of the things that we're doing at ACT is we're building a mobile platform to disseminate information that ACT knows about to the students. And that includes the whole spectrum of the holistic framework. So not just what do we know about you based on your academic data from the ACT test that you took, but if you took other things from sport keys or played this game, for example, all of this data is going to get funneled into one mobile app. So here you can see I've clicked on a particular math area. The students can drill down into this area, and they can basically get a cognitive diagnostic model of what they were getting right and wrong within their assessments, what they got through their practice sessions, if they did any test prep. So for example, the student can see that they might need to work on ratio of proportions based on their star rating there on the side. We have just acquired another company called OpenEd. We were talking before about resources on the web. OpenEd is one of the leading curators of open educational resources. They're non-ACT element, and what we're doing is we're linking all of our OpenEd resources. So once we build these cognitive diagnostic models, we recommend to our learners very targeted, specific modules within OpenEd. And as I mentioned, just like we see with the academic areas, things like perspective taking, persistence, problem analysis, they're all inside our holistic framework as well. And so the idea is that evidence from the game is going to come into this app as well too. And we actually have professional development resources to help students or help teachers help students improve in things like persistence and problem analysis and openness. And what we're going to do is start creating those into online modules that can be linked into apps just like this, so students can actually work on particular behavioral areas as well using this app, alongside they would with any of their other academic skills. So going forward, we're interested in working on new developments in this area, expanding out of this single fixed agent into human-human agent, allowing students to collaborate with other humans while playing the game, and also to go beyond simple selecting items in a fixed conversation tree, allowing them to express in open natural language and doing NLP processing of those interactions as well too. That's sort of the next phase of our work. That's it.